So good evening to you all. Welcome to the continuation of chapter 2 and the beginning of chapter 3. Now on chapter 2, we've talked about many things. We talked about different chemical laws and equations, talked about empirical formula, molecular formula, and percentage composition by mass. We talked about some other things, that is talking about atom and atomicity, talk about different name of scientists. And in the next chapter, we are going to focus more on atoms, molecules, and ions. We are going to talk extensively on how proton, neutron, and electrons are being discovered and the name of the scientists that did that. But for now, we want to complete the chapter by doing the remaining part and answer all the questions for today's class. So our aim for today's class is to finish up with the remaining part of the slide. And if time permits, we can start with the new slide. So don't forget, this slide we talked about, I can quickly go back, empirical formula and molecular formula with percentage composition. We talked about Galois law and Avogadro law of combining volumes. We talked about different law of chemical combinations. We talked about the interpretations of all these laws. And we as well talk about doubting postulate. And we talk about some calculations and the application. We started with examples in the last class, but we did not actually talk about the stoichiometry aspect, which is also needed because of time factor. We started the questions, and I think we were able to solve this side. I gave you this remaining part as an assignment, so which I'm going to check in now. Then also, before I continue, I am going to finish up with the remaining aspects. Now, let's start with mole concept. Now, about mole concept, I will just make it short. Like I said, Jamb questions or Jamb syllabus only require you to know the applications and not that you just know the definition. Now, you can just write a simple thing. This aspect is called the stoichiometry, but we are only going to focus about something. We've talked about balancing equation as it obeys the law of conservation of mass or matter. So now here we want to talk about some simple application. Now, you can just write a simple thing like a mole is just, let's say simple definition, a number. A mole is just a number. And a number is called Avogadro's number. Avogadro's. Now, another thing we can keep in mind is that the Avogadro's number is a constant. The Avogadro's number numbers, this I use abbreviation, is a constant. The constant value given us 6.02 times 10 raised to the power 23. 6.02 times 10 raised to the power 23 atoms. So let's say this is the value. I'm not putting a sign because I said it is a number. Now we can also say the numbers of moles, of a substance, or an element is represented numerically by three ways. Now, the first method we use is what we call the numbers of moles. This first right is equals to the mass given over the molar mass, or you say the molecular mass. Very important. The second one is the numbers of moles equals to volume given over 22.4 decimeter cube, or you say liter. The third representation we use in chemistry is the numbers of moles. This thing is loading as usual. I have to wait. The numbers of moles is given as it's loading. I'm waiting for it to pop up. You guys are not new to my class. You understand better. It's almost done. The numbers of moles is given as, okay, I think it's back. The numbers of moles is equals to the numbers of molecules over Avogadro's constants, which I just gave you now. This Avogadro's constant, I just write it as 6.02 times 10 to the power 23. So now, these three formulas I have listed here are the most essential formula that we use to correlate solving question when numbers of moles is what you are looking for, and you are given the mass and the molecular mass or the molar mass. The situation whereby you are given volume. So in most of your textbook, the textbook, we want to elaborate an explanation to make sure you guys understand it. That is why you see moles to volume, mass to mole, moles to molecule, whatever. So numbers of moles is numbers of molecules. Sometimes if you don't see numbers of molecules in this case, you are going to see it as numbers of particles. Now, what do we call molecule? All these are going to be treated well in chapter 3, where we are going to talk about definition of molecules, definition of ions, definition of atom, composition of atoms, quantum number, configuration, and so on and so forth. But for now, we limit ourselves to what is needed and the application of these three formulas. Now, I can also help you add one more formula, which I think is going to be important later as we move forward. As also you can write the numbers of moles is equals to concentration multiplied by volume. So keep it in mind. I always call this one N is equals to CV. This is also very, very important for you guys to know, because if you know all these aforementioned formulas, you can actually attack, let me use the word attack, permit me to use it. You can actually attack any form of questions from Stoichiometry. Now, I'm going to give you some simple examples here that correlate all these guys. And let's see, before we now go into our question per se. So what we want to do is to finish out the question, which I think there are many. Yes, there are many. Many of them are there. But at the same time, we have to understand how it's being used. Let's see some examples I'm going to give you. So the first one I'm going to write out here is going to be, let's say we have how many moles is required. Hey, you guys know why I'm laughing. Just write your own spelling well. How many moles is required for 10 grams of CaCO3 to completely react with hydrochloric acid, HCl. Let's take it one by one. Now, in this question now, we are just looking for the numbers of moles that is required for 10 grams of CaCO3. Yes, most of the exams is going to give you in brackets. Ca is equals to 40. Carbon C is equals to 12. And oxygen is always equals to 16. Whether you like it or not, this is going to be given. So now, what I want to talk about now is just for you guys to understand how it is being done. Now, There's no reaction involved in this type of question because I'm looking for the numbers of moles. How many moles? Okay, how many moles of this? There's an omission in my question. How many moles of CaCO3 is required? Is required for 10 grams of CaCO3 to completely react with HCl. Now, most of your teacher might have said, okay, directly you can just say this question, you have to write the equation of reaction. But I can tell you, with this type of question, I may not write the equation of it because it's more like a direct question. I'm given the mass, and I can get the molar mass of CaCO3. So I can easily get the number of moles from the first formula, which is 2. So for instance, now to solve this one, I can say, okay, fine. The molecular mass of CaCO3, and now write CaCO3, the molecular mass for the Ca is 40, plus C, that is the next, is 12, plus O is having a substrate of 3, so we say 3 times O was given to be 16. On simplification, this guy is going to give us 40 plus 12 plus 48, which is 100, plus 12 plus 48, so which is 100 grams. So now 100 grams per mole. Anyhow, so you can now go by the formula of numbers of mole or numbers of moles is equals to mass given. You can see that the mass was 10 over molar mass, which is 1. So when you put your calculator or whatever, it's 0.1 of what? Yes. So it's a kind of direct question that obeys the first law directly. So now let's see a combination of 2 laws and see if we can do that. Now let's take another example. Another simple example before we start our questions. And doing so, I'm not going to be, I want you guys to be seeing the formula so that it will actually ring true to you. Now look at this. We have this simple one. We have, let's say, okay, 9.8 grams of H2SO4. Required how many moles? How many moles? Complete reaction. That's one. Another one I'll give you guys 22.4 GMQ of oxygen gas is used. 22.4 GMQ of oxygen gas is used during the reaction. During the reaction at STP. At STP, then the question is calculate the mass of O2 gas, calculate the mass of O2 gas, calculate the mass of oxygen gas required at STP. So in brackets, I'm just giving you a simple question. O2 is equals to 36, 32 grams. So let's just look at this. This second question here is more like also a direct question because nothing is reacting with anything. I will just do it by the side directly. Now from the formula I've given to you, you just look for what actually satisfies. Now in this case, what satisfies is still the first formula. We know the mass, we can get the molar mass of H2SO4. Even though it is not listed, most of your question is going to put it in brackets. Hydrogen is 1, sulfur is 32, oxygen is 16. So Now, it's just like, I'm not going to solve this one, just directly, just use the same formula I have here. Numbers of mole is equals to the mass. Mass is 9.8 over molar mass. If you calculate molar mass of H2SO4, should be 98. So the same thing, 0.01, you are going to get your answer. So these are how to get answers for questions with the first one. But look at this, the third example. It is talking about molar volume of a gas. Now, there's one thing I just quickly want to talk about because I have given you a formula. I will scroll down a little bit. That numbers of moles is equals to volume given at over 22.4 decimeter cube. Or sometimes, if you don't see decimeter cube, it can be in what? This thing is still loading, and I still have to wait. I told you guys that in the next class, I'm not going to be using this whiteboard because it's always slowing me down. At least it always takes at least out of my time. Let me say 20 or 10 to 12 minutes out of my time. It's 1 minute, 2 minutes loading. So as I wait for it to come up, I said, what we call, because you can ask me that, okay, fine. Where is this 22.4 coming from? Well, like I said, it's that question. Nobody will answer you because nobody is talking about experiment here. So 22.4 DMK or liters. So this particular value is called the molar volume of a gas at STP. Molar volume of a gas at standard temperature and pressure. So how they come about it was actually from what we call the gas law, which we are still going to talk about later. Is you need to be attentive and you need to know what you are doing. So when you are, this formula is only applicable when we are actually considering a gas. If a gas is not in your question, you can actually use number of moles volume over 22.4. We are going to do more questions on that, but I just want to give you simple ones first. Now, to solve this one we have here, you can see that we can think about 22.4 DMK of the gas. That means we are giving the volume of that gas at STP. It's of a gas O2 is used during a reaction, which was not mentioned. So we don't need to write any equation of reaction. Calculate the mass of O2 required at that STP. Wow. So now I think we are going to apply two formulas because the first one is going to be, numbers of mole equals to volume given over 22.4 decimeter cube. Now we are giving the volume as reactant. The volume given is 22.4. And in bracket also, the examiner will give you molar volume of a gas. But even if it is not given, it's already in your formula. Now the question can be, the example I'm using, I use 20.4 decimeter cube too. It might be 11.2, it can be any other thing. You understand? This is the volume of this gas. Now, whereas the volume at STP is constant, which is 22.4. Please be careful. Or for us not to have confusion, let me change this value because I know students very well. Might be like, how come? So you can just change this to, let's just do something, 11.2 DMK, so that you understand that in the question, the volume of the gas at STP is 22.4, but the volume given is what? 11.2 divided by 22.4. This is a constant from your formula. From here, you can actually solve this from here and get, this is 1/2. I think this is 0.5 moles. You can help me confirm that. But the question did not ask to calculate what? The mass. So that means you have to use another formula that says numbers of moles is equals to mass over molar mass. So in this case now, you know the numbers of mole, you are looking for mass. You know you have to cross multiply. So you can say the mass here is equals to the numbers of mole, that is 4.5, times the molar mass that was given, times 32. So directly, this is going to give you 16 grams, and this is going to be the answer to your question. So sometimes you might be required to use more than one formula to get your answer. It is possible. In a similar development, I'm going to take one more simple example, or should I call it two? I think one would be okay, so that we can start and finish all our questions, because all those questions can take us up to 2 hours because of volunteering and all those things. Now, fine. Now, this next question, next example will be in terms of equation. Let's say KClO3, I just want to give you, is a kind of reversible reaction is being heated to give us KCl plus O2. See, this is a reaction you are still going to know more about later. In the presence of manganese 4 oxides as a catalyst. This is reaction of oxygen. Now, we have to balance, I think 2, always balance oxygen last, 2, 3. Yes. So the question is, according to the equation, I'm just forming all these questions from my head. According to the equation, what volume of oxygen gas is required? What volume of oxygen gas is required at STP for complete decomposition? So in brackets, molar volume of the gas will be given, and that is 22.4 decimeter cube or liters. Please note that it can also be in liters. So now, to solve this one also, these are questions in which we are going to use formula and equation. Now, we first of all check, is equation balanced? Yes, equation is balanced. Fine. So how do I get volume of a gas? The formula is number of moles is equals to the volume given over 22.4 deciliter cube, or decimeter cube. So now, in this case now, I'm looking for the volume. The number of moles is also, or number of mole is also defined as, nobody will ask you this definition, you are not writing my head, but number of moles is also called the stoichiometry coefficient. The stoichiometry coefficient. Now, in this case now, you can say, you know, the language form when we talk about Gay-Lussac's law and Avogadro's law the other time, I told you guys that, fine, this, what we call, what's it called, chemistry is very simple, if you understand. Now, you can say in this question now, in this equation like that, what is the number of moles of potassium triisochlorate 5? It is the number of stoichiometric coefficient that is standing in it. Now, if you want to write it in language form, it's like saying, okay, here, according to the equation, 2 moles, you know, you understand, of KClO3, the way your teacher will write it, which I don't give a damn right now, require, because you are comparing it with what oxygen gas, 3 moles of oxygen gas. But nobody is asking you for any comparity here. I hope my English is good. And any comparison, not comparative, please. Apologies about that. Now 2 moles of potassium triisochlorophyll require 3 moles of oxygen. Then, if you are not saying how many moles of something we require, but in this case, you are only focusing on the gas. This guy and this guy are not the gas. The question is, according to the equation, excuse me, what volume of oxygen gas is required at STP? So now I need to know the numbers of mole of oxygen that is reacting. What is the numbers of mole of oxygen reacting in this equation? You and I can see this 3 moles. So I can also 3 moles equals to, I'm looking for the volume over 22.4. So directly I can say in a nutshell that volume will now be equals to 22.4 times 3, that's 67.2 decimeter. So that's that, and that's the answer, because I know the number of mole from the equation. So number of mole is also called the stoichiometry coefficient, and that is that. That means that is very simple. Now, in some equation, you might require comparison. Maybe I do one more before we go into questions, because I do say if I continue to teach, I can continue to teach for the whole day. You know, concept cannot finish, but you just need to focus on what is going to be asked. That is just it. Now, the next thing we can also talk about is mass to mole. Let's say a very good example of this. An example of this should be, let me just say 10 grams of CaCO3, CaCO3, okay? CaCO3 react with hydrochloric acid at STP to produce oxygen gas. What's a lot for me question from my brain? What volume of oxygen gas is required? What volume of oxygen gas is required? This thing is loading again. Whenever you see me writing and nothing is popping up, I have to wait for the stuff to load. And I think it's really delaying me. It's really delaying me. I'm waiting for it to come up. What volume of oxygen gas you can be writing is required for complete reaction? For complete reaction. I'm waiting for it to come up. What volume of oxygen gas is required for complete, is required, I think it's back, for complete reaction. We can say in brackets, Ca is 40, C is equals to 12, O is equals to 16, and that is all. Then you can also say Cl equals to 35.5. H equals to 1, Cl equals to 35.5. And write that if you want. So now, how do we solve questions like this? Now, to solve questions like this, you have to write equation of reaction. In UTME, in Jamb, you are going to, the equation of reaction is going to be written for you. But in case the equation of reaction is, so these are simple ways. This is one of the methods, laboratory methods we use to prepare CO2 by reacting CaCO3, limestone. We've talked about this reaction when we are talking about law of conservation of mass, if you guys remember, plus hydrochloric acid. The reaction goes like this to give you CaCl2 plus water plus CO2. I told you, whenever acid combined with metal carbonate, it gives you salt, water, and CO2. You can keep it in mind. Acid plus metal is calcium, carbonate is CO3. It's going to give you salt, water, and CO2. That is how to, most of the metals are metal carbonate plus what? Acid. It's going to be like this. So, you know, equation must be balanced. So let's try and balance this, guys. Always balance oxygen so that you don't have problem. Hydrogen is 2 here. So let me start with hydrogen 2. This guy is 2. This guy is 2. So balance oxygen first. Oxygen is 3. Oxygen is 2. So what will I do? Oxygen is 3. Oxygen is 2. Fine. I think it's balanced because this is 2 plus 1, 3. And this is 3. And this is 1. And this guy is 1. And this guy, you can see it is balanced. So fine. Now look at the reaction. The reaction gave us the number of mass of CaCO3. But the question is asking us to calculate the number of the volume of, it's not O2, volume of CO2. Change the question to CO2. Apologies about that. The volume of CO2 gas that is produced, not O2, guys. I told you I'm taking question from my head. Now, to solve this one, we are going to compare two equations. We are comparing, look at it. It is the nature of the question that tells you what you are comparing. I'm comparing what? CaCO3 with CO2. It's a simple question. So in this situation, I can say, oh, wow. From here, stoichiometric coefficient is the mole. 1 mole is just a number of this guy. 1 mole of CaCO3 require how many mole of this guy? 1 mole of CO2 gas. Because this is a gas. Now, mole is just a number. Listen to me, guys. 1 mole of a substance is equals to, that's where what I want to talk about the other time, is equals to its molar mass or its molecular mass. So 1 mole of a substance is the same thing as its molar mass. 1 mole of a substance is the same thing as its molar mass. So 1 mole of CaCO3 is the same thing as molar mass of CaCO3. So guys, I'm asking you, What's the molar mass of CO3? So if it is 2 moles of this one, it will be 2 times. You remember how do you even come about that? Numbers of mole is equals to mass given over molar mass. So what am I trying to do? It's like I'm converting this mole to mass so that I'll be able to actually solve this question. Because at the end of this, I want to know the number of mole that will be required. So for this one, but according to the equation, 1 mole of this one requires 1 mole of this one. So let me see at the end of the equation, maybe I'm still going to have it in terms of, like you can say, if you convert moles to mass, mass is equals to moles times molar mass. So 1 mole of a substance is the same thing as the molar mass, fine. But 2 moles of a substance is not the same thing as its molar mass. 2 moles of a substance will be 2 times the what? The molar mass to get the mass. So to compare 1 mole of CaCO3, the molar mass is 100 grams. We did this the other time. You can do that 40 plus whatever plus. I don't have time. Require and convert it to what mass now? 1 mole of CO2 is 44. You can see 1 times its molar mass. Molar mass of CO2 is 44 grams. I'm not going to waste time. How did I get that? C is 12. 2 times 16 is 32. 32 plus 12 is 44 grams. So I've converted the mole to mass by using this simple formula. Number of mole is mass over molar mass. So that means 100 grams require. But if this guy is 2, it will be 2 times 100. It will be 200 grams. If this guy is 4, it will be 4 times, as in it depends on the stoichiometry coefficient. So 100 grams require 44 grams. I believe I'm talking. You will now say, fine, how many grams was now given? 10 grams of CaCO3. This is what is reacting. So therefore, 10 grams will now require X. I'll take that again. The question says only 10 grams is reacting. Okay, fine. Let's convert the number of mole from equation to mass. We convert 1 mole of CaCO3 to mass. It gave us 100 grams. 1 mole of CO2, because we are comparing this guy and the gas, CO2. So 1 mole of CO2 gave us what? But in the question, only 10 grams of, so under CaCO3, that is only 10 grams. We now react to give us how many for CO2, which is X gram. This is the conventional method of solving chemistry question, which almost all the teachers in your school will have explained in one way, would have explained in one way or the other. So now what we do is just cross multiplication. What we do is just, because we are multiplying X, this is X, with 100. So what we are saying is that if we make X over a formula, this 100 can never be on top. It will be this guy and this. It will be 10 times 44 divided by 100. So keep that in mind, because X is multiplied, that's like 100X is equals to 44 times 10. That is 440. So X will now be 440. You know, it's the same thing as what I've done here. So X will give us 4.4 grams. So 4.4 grams of what? Of CO2. But the question did not ask you that what gram of CO2. The question asks you what volume of CO2. You can see that it's a kind of long question, and I did it intentionally. So how can you get volume of CO2? That means you still have, this is the only amount of CO2 mass that is reacting or that is liberating according to the equation. Now, what will I do now? I will now use my simple formula. Number of mole is mass. Mass is now 4.4. I don't want to waste time. Over molar mass is 44. Molar mass of CO2 now is 44, and that is the 0.01. Please just confirm that. If it's not correct, correct it of this. But the question is not asking me that what is the number of mole of CO2. The question asks me that what is the volume. You can see what I'm talking about now. So I still have to continue to use the what? The one that connects mole and volume. What is that? Number of moles is volume over 22.4. So this is what will help me to finalize to get my final answer. And from there I can solve. So I can say volume is now equals to the number of mole. What is number of mole? Is 0.01 times 22.4. So, and that is how to get a final answer to this question. So which will be 0.224. So whatever. So that is that. You can see what I talk about. Because only 10 grams of this is reacting in this. So 10 grams, we convert it to mass. According to equation, 1 mole of this requires 1 mole of this. So 1 mole is 1 times the molar mass, then this. Then 10 grams of this guy will now produce how many grams of CO2? it yielded 4.4 grams of CO2. Then we use our number of mole. That means if the question says calculate what mole of CO2 is required for the reaction. So the number of mole required for the reaction is 0.01. But the question did not ask for the number of moles, but rather ask for the volume. So then you go to the second formula as a number of moles equals to volume over 20. So by now, you should have understand how to use the two formulas very well. So the third formula is kind of very simple and direct. The third formula, which I gave you, because I'm yet to talk about it, time is always a problem. The third formula is the formula of, let's just take one example. Calculate the number of molecules. I told you can be numbers of molecules. This thing has started angry again. The number of molecules or the numbers of particles. Please note that. Calculate the numbers of molecules. It is hanging. The numbers of molecules required, you can write, I'll just be dictating from my head. The numbers of molecules required, the numbers of molecules required, calculate the numbers of molecules required. I think it's that, hopefully. Calculate the numbers of molecules required for 10 grams of, let's take CaCO3 to react with HCl. In brackets, they'll give you Avogadro's constant. Most times they write it as Na. Let me write it the way you will see it, so that it won't be as if Avogadro's number is 6.02 times 10 to the power 23. So now, you can see the formula that relates number of molecules, numbers of substance or numbers of moles is equals to numbers of molecules over Avogadro's constant. So now what you do from here, guys, is, well, you never know the numbers of moles. Then you come to the first formula. Numbers of moles is mass given 10 over molar mass. They will give in bracket also Ca is 40, whatever. Molar mass of this thing you are used to it is 100. So this guy, number of moles is 4.1. So you now come back, numbers of moles is 0.1 is equals to numbers of molecule, I can call it X. AC is given, or Na, 6.02 times 10 to the power 23. So on simplification, number of molecules is just when you cross multiply these two guys, then you have your answer. It will be 6.02 times 10 to the power 22 molecules or particles or atoms. Anyhow you see. So that's that about my explanation. And I think I took my time. So now the combination of all the questions are now what we're going to face for the next hour. So I think we cannot even start chapter 3 today, because we are still lagging. So it's time for you guys to move to the questions, and let's see what we can. So before that, you guys have 5 minutes break. As usual, 5 minute break for you to take water, because we have a long way to go in questions. So this is the question slide. We have done this part. And how do we run the questions for newcomers? We run the question by taking volunteer. Volunteer simply means the person that is going to unmute his mic and flow with me. Flow with me simply means, because I have to break it down, someone who is definitely going to just tell me how we can talk together on how to solve the question. It does not necessarily mean that person or the person must be the one that will solve the question correctly. So the question must be with calculator, if calculator is needed, and the person must be ready to take the question with me. I repeat, not necessarily maybe the person must get the answer or must. So volunteer is always something you should be ready to do, because it makes you to get it better, because I'm definitely going to be helping you on one or two things. So note that. So that's that about that. Like I said, 4 minutes more for you to prepare for this class. Thank you. I'm waiting for you guys. So I will continue in 8:40. So you remain here. You can start practicing. This is an assignment, but I'm going to start from that too. So let's see how it goes. So I think it's time for us to continue. So I believe we are back. I think some students are still missing there. Yes. So let's start. I think for now, there are 5 now, I guess, so we can continue. Okay. Okay, fine. So let's start. Balance equation, this is it, please. It was an assignment. Okay, when I ask you to unmute your mic, you just know you are the volunteer. So we have, can see that. Please, let's do this together. David, please, let's start.
Okay, sorry.
Please, because you understand better.
Okay. The balance equation for the reaction of tetraoxosulfate 6 acid with aluminium hydroxide to give water, and aluminium tetraoxosulfate 6 is a. Should I read the option, sir?
I can't hear you. I think I have to change something. Come on, just a minute, please. Just a minute.
Okay.
Please stop, David. Talk now.
Okay. I said the balanced equation for the reaction of tetraoxosulfate 6 acid with aluminium
Okay, just hold a bit,
hydroxide.
hold a bit. I think I know where this thing is coming. It's actually coming from. Let me just. Okay. So, David,
Okay,
you were
sir.
saying,
Yes,
yeah,
sir.
this together. Yeah, thank you.
The balanced equation for the reaction of tetraoxosulfate 6 acid with aluminium hydroxide to give water and aluminium tetraoxosulfate 6 is. Should I read the option, sir?
Yeah, you don't need to read the option because of time. Now, you just focus on, this is balancing equation questions, have you? So, like I said, the logic is always balance oxygen level. So just look at how many moles of oxygen to balance. Now, we don't have time. Now, the only correct option is, how do we write, because I love this question, aluminium tetraoxosulfate 6. Now, aluminium tetraoxosulfate 6 is what is going to be formed. So it is written as aluminium is Al2SO4 all thrice. This is the only correct one. So that is the only thing you are going to be looking for. So it's going to be water. So you have to be very, very attentive, watch carefully. So, and for aluminium hydroxide is AlOH all thrice. So that is the way. So those are things you need to check. Which of them has this property being written correctly? So I think option D is correct. Yes. You can enlarge these things on your screen. I can as well help you to enlarge. You guys cannot see them clearly. Help you enlarge them. So please note that. I don't know, because I don't want to hear my enlargement speak, so that it will be kind of very clear and very visible. I don't want a situation whereby. So let's just do it like that. So now option D is correct. Like I said, I've increased the stuff. Now, how did I know it's correct? You can quickly check balancing equation from here. How many moles of oxygen do we have at the left-hand side? 6. Abi, look at here, 6 plus, look at it, there is a 3 here, there is a 2 outside. So it's like saying 3 times 2, that's 6. 6 plus 6 is 12. Check oxygen. I said oxygen, hydrogen. Check hydrogen now. 6 times 2, 12. Balance. So it's balanced. So you also check sulfur, it's balanced. You check oxygen. Look at oxygen. 4 here, 4 plus, this is 3 times 2. 4 plus 6 is 10. Check oxygen. 6 plus, or let me check oxygen very well again. Oxygen here is 3 times 4. You can see there is a 3 outside, and so is 12. Then plus, this is 3 times 2, 6. 3, that's 12 plus 6 is 18. Check oxygen. This is 6 plus 12, and that is 18. So that shows option D is very, very correct. So that, thank you very much, David. During the course of your volunteering, your mic will still be unmuted. So you don't need to mute it back, because we are talking and explaining to others to get what we're talking about. So it's like we are chatting to explain things. You understand? So thank you. The next volunteer here is going to be, you can mute back. We are done. Next volunteer here is going to be Newman, Jamb Newman. Please, Jamb, let's take me through the next question. I think we have solved this next question. Is it this one? Please, let's talk. Jamb, are you there?
Yes, sir.
Have we solved this question, this particular one?
I don't think so. I think that one.
Okay, we've not. This one. Okay, it's not this one. Okay, let's do it. What is this particular question testing us? What do you think it's testing us on? Yeah, I'm with you.
Empirical formula.
God bless you. Empirical formula. So how do we do that very quickly, so that because it is Jamb, nobody needs you to waste time? So you just write carbon, right? So yeah, let's take me through it. 72. Hydrogen.
Hydrogen 12.
Then oxygen.
And oxygen 16.
Is everything here up to 100 to confirm? Yes, it should be, right? Yes. So what do we do next? We divide by their what? Their molecular mass, their molar mass. What's the molar mass of carbon? Please take me through it. Let's be fast because of time. Molar mass of carbon?
12.
Divided by 12. Hydrogen?
1.
Then oxygen?
16.
Thank you very much. So 12, 6 are 72. This is still 12. This is still 1. What's the next step at Jamb test? We divide by what? The smallest number.
The smallest number.
What's the smallest number here? That's still 1. Divide by 1, divide by 1, divide by 1. So we write our answer. C, 6 divided by 1 is 6. H,
yes.
12 divided by 1 is still 12. Then O, we don't write anything at that time. So that should be the answer. You look for it. If it's not there, that is their problem. So thank you. Next volunteer for the question. I think this is also choice D. The next question is question 17. My volunteer for this one will be Ibrahim Molar. Please unmute your mic and let's do this together. Please, no time. Thank you very much. Please always make sure you are in a place that is less noisy. Very important for understanding of others. Now, take me through this. Read the questions that we still go together.
Given the molecular mass. Can you hear me, sir?
Yes, exactly. I'm hearing you, please. I'm hearing you.
Given the molecular mass of iron is 56.
Molecular mass is 56. I'm with you. Molecular mass of iron is 56. And that of oxygen. Thank you very much.
Yeah. How many moles of iron oxide will be contained in 1 kilogram of the compound?
So thank you. This question is testing us on what? Stoichiometry. Am I right?
Yes, sir.
Thank you very much. Now, that means we have to talk about, we are looking for the numbers of moles. But before we can actually get that, number of mole is mass over molar mass. We are giving the molar mass of this, the one that is supposed to be given in bracket. Please back your mic. You are very close to a TV set or radio there. You are not supposed to sit close to a radio. Please. Now, for this type of question, guys, because of time, now, this is what is supposed to be given in brackets. The mass was given in kilogram. And please, mass in chemistry should always be in gram. So you convert it back to gram, it should be what? 1,000 grams. So what you just need is a mass over molar mass. Molar mass of what? Moles of iron 3 oxide. But they are not telling you iron 3 oxide is being produced. That means you have to write the equation of reaction. Iron combining with oxygen. We give you iron 3 oxide. How do you write iron 3? Iron 3 oxide is written as, because this is where something is. Some people don't know how to write iron oxide. Iron oxide, some people say, is it Fe2O3 or Fe3O4? Now, if you don't know the correct formula for iron 3 oxide, we are going to help you to know it too. Now, iron 3 oxide is Fe2O3. Oxidation state, we are still going to talk about it when you get to the topic. So, iron combined with oxygen to give us iron oxide. This is called iron 3 oxide. This is the reaction. So, what you just need to do here, my dear student, is just to follow the formula of numbers of moles is equals to mass over molar mass. I know Jamb test is saying in his mind that are we not going to balance? Yes, we are going to balance. 2 is here, right? And when 2 is here, you know something must change here. This guy, we also have 2. So this is oxygen is now 6. So 3 times 2 is also 6. This is a complete equation of iron 3 oxide. So iron 3 oxide mass was given to be 1,000 over the molar mass of iron 3. What's the molar mass? You know how to calculate that. Fe2. So let's do that. Please, molar mass, you are not taking these 2 at the back because we are not comparing any equation. We only need the molar mass of iron 3, which is Fe2O3. So Fe2O3, let's do that together. This guy is loading. I am waiting for any volunteer to tell me the molar mass of Fe2O3. Iron is given as 56. Oxygen is given as 16. You are calculating the molar mass of Fe2O3. Any volunteer, please? What is the molar mass? If you are ready, just unmute and tell me. Yeah? You said what?
160 grams. 160 grams. 160 grams.
160 grams. Thank you very much. So he said 160 grams. So that means this will be divided by 160. So on simplification, we just divide 160 by this. That should be like 6.25. So is it up to 6? Yes, it should be up to 6. I am not sure, but I think it should be 6.25. That's a closest answer. If you spot any error, you can drop that in the chat box. So that's the answer for these two. Option C is correct. So next volunteer is going to be at Ayomide. I ask you to unmute. Let's do that ASAP. So let's do it together. Are you there? Okay,
yes,
fine.
sir.
Now, the question is testing us on what, please?
Atom.
Number of atoms. That's stoichiometry we just talked about. Now,
yes,
the formula we are going to use was the first, should be the third formula we talked about. Am I right?
Yes, sir.
More like the last example I did. Is that not so?
Yes, sir.
We are given mass, and we can get the molar mass to get the number
Molar
of moles.
mass.
Yes, so I think the first thing we are going to, let's do that together. Your calculator should be by your side because I don't have. So we need to get the number of moles first. Number of mole is equals to the mass over molar mass. What's the mass, Ayomide? The mass,
5.85 gram.
Very good, over the molar mass. Now you need to get the molar mass of NaCl. I don't know, but it will be given in bracket. Sodium is given to be 23.
23
Plus fluorine is given
plus
to be
35.5.
Thank you very much. So this should be 58.5,
sir.
Thank you very much. So the molar mass is 58.5. So the number of moles should be, tell me from your calculator, I don't have, 5.85 divided by 58.5, 0.01 what?
0.1.
0.1 moles. So 0.1 mole is what is here. But that is not what the question asked me. Number of atoms. I told you it's exactly what I asked you now. So the last formula, number of moles, remember?
Yes, sir.
Take me through it. Is equals to number of atom or number of molecule, right? Over.
Yes, sir. Over
the what? Avogadro's constant. Abi? So what's the number of?
Yes, sir.
What's the number of mole here? We just did that. Number of mole is
0.1.
Thank you very much. Is equals to, we are looking for the number of atoms or number of molecules divided by Avogadro constant is always constant. It will also be given in bracket of your question.
6.02
times 10 raised power 23. So I told you it's more analyzed like what we did. So the final answer will be numbers of atoms is equals to 6.02 times 10 raised power 22. Because if you multiply 0.1 times 10 raised power 23, it's going to give you this guy. So I hope you understand that. So that's the answer.
Yes,
that would tally with option A. So thank you very much. You can mute your mic back. Thank you very much. Now, the next question, volunteer will be David. Yet again, balancing equation. David, please.
Okay, what are the values of x, y, and z respectively in the equation?
So now it is just like even if you don't know how to balance, you can just plug in. I think plugging in would be the best method to tackle this type of question. So maybe we should plug in and see. Now, I am not going to be showing you, okay, this is one magical moment that I'm going to use to get the answer to this. I don't have time, but the truth about it is just, you need to just plug in. So let's plug in. What do you think would be the best? I don't know.
4 copper should be
4 copper. I don't think so. Okay, you're trying to do it. Okay, I'm waiting for you. I am waiting for you. Why waiting for you? If we have another volunteer, please mute your mic, David. Any other volunteer that is ready? Now the shortcut, I'm going to clean this side so that we can have space. Because we've done this side so that we can have space to show our skills. Now, all this problem or whatever is not needed. Listen to this shortcut. David, please unmute your mic and let's talk. Let me take you through it. There's one particular thing we call twin equation. There's a particular thing we call twin equation in chemistry. That is, when copper reacts, you can keep this in mind, with HNO3 in chemistry. We call it twin equation because it is twin because this guy can be diluted and this guy can also be concentrated. So please, mastermind this twin equation, and you don't need to disturb yourself saying you want to be plugging in. Now, if you plug in where, I can tell you, because this reaction is going to be a reaction of what they are being formed. Now, if it is a dilute reaction, when copper combined with dilute HNO3, that is triisonitrate 5 acid, if it is dilute, this is what you are going to have. You are going to have copper nitrate, that is CuNO3 or twice. You can keep it in mind for next what, for some questions that you are going to come across in future. Plus water, then plus NO, that is nitrogen oxide. So the logic I always tell students is the equation is 3, 8, just cram it, master my memorize, 3, 8, 3, 4, 2. 3, 8, 3, 4, 2. That's the equation. When copper reacts with that. So you don't need to disturb yourself. It's very, very simple. When it's this one is placed, when it's liberates NO, it is not dilute, it is concentrated. But when it liberates NO2, look at the second one, copper, the same copper, plus, that's why we call it the twin equation, plus HNO3. This time around is dilute. Now, the same thing, but look at what is going to happen. It's going to be copper nitrate is constant, CuNO3, or twice, plus, you can see, plus, this time, plus water. This guy is water, not NO2. This guy, H2O, now water and nitro. Plus water, plus this time around, it's now going to give us nitrogen 4 oxide. So the difference, this question also, you come across it later when we start more of our chemistry, like which one is following is the correct reaction of when copper reacts with dilute or when it reacts with concentrate. If it is conc, it's NO, nitrogen oxide. If it is dilute, it is NO2. Keep that in mind. Now, the magic formula for this one, this guy is not going to carry anything. This guy is going to have 4, but this is always what they will ask you. This guy here. Now, this also will not carry anything. Then these two guys is going to carry 2 and 2. But they won't ask you this one because they know this one is kind of very easy to balance. Because the only thing that is carrying something is 2, 2. Yeah, guys, this guy is 4. But they will ask you this one of 3, 4, at 3. I told, okay, I don't know where they put their X and Y and Z, but this is a kind of equation that I know. Well, it's not a big deal if you don't know. You can start plugging in and check which one goes with it. So from my explanation, David, what do you think will be the correct answer to this question now?
The correct answer will be B, 382, sir.
Thank you very much. Mute back your mind. I appreciate that. Next volunteer is Jamb. Jamb, please volunteer to take us through the next question.
Thank you, sir.
Thank you.
The formula of the compound formed in a reaction between a trivalent metal M and a trivalent non-metal X is dash.
So what is this thing testing us about? Valency, right? That we've talked about. Are you there with me? It's actually testing us about valency. How well do we know valency? M is a trivalent. I told you that means 3 plus. Remember? X, the second metal is what? Tetravalent. What does that mean? 4 valence electron. According to Berzelius rule, what do? We cross multiply. Are you there? Yes, some of your teacher will write the 3 under and the 4 here. They will now cross under. They will now say M. What happened? The 4 come and marry this guy, and the X will take over what? The 3. So this is what you are going to be looking for in the option. So we establish with what option? Which of the options? Which of the option? This, I think it is this. Choice C.
B. C.
I think it's C. Yeah, C. So thank you very much. So next volunteer is going to be Olaniwaju, please. At Olaniwaju, please.
The number of atoms in 1 mole of the substance is equal to the...
Can you take me through that? I think that's it. Thank you very much. That is what. Number of atoms is same thing as Avogadro's word. Number of atoms, number of molecules, number of substance is called mole. The number of atoms is same as number of mole. So a mole is just a number, and it is what Avogadro's number. Thank you very much. The next volunteer is going to be Ayomide. And now I'm going to leave Ayomide not to be the next volunteer, simply because Ayomide was not here. This thing is hanging. I'm going to say it was not here when we talked about this. So that means the next volunteer, I'm going to pass Ayomide, is going to be at David. Yes. But David, because this is texting us on our chemical laws, which we talked about in the last lesson. So while waiting for this thing to load, David, please kindly unmute your mic and let's talk about this question. So I am through with this guy too. I think I can actually delete this guy too, and so that I will have enough space to talk about this guy here. So David.
I'm trying to look for the questions. Okay. In an experiment,
Thank you very much.
5.00 gram
I'm with you.
of a metal gave 10.559 gram of its chloride.
So 5 point, I want you to take it listen. You should learn how to be what? How to explain to others. You are leading them to understand. So what we have is 5.00 gram. You can just write 5. Yield what? 10.5 gram of what? Of chlorine. Abi, the first experiment, 5.0 yield 10.5. That's the first experiment. You move on.
In another experiment,
yes, another experiment.
Gram of metal.
Gram of a metal, yes.
Combined with 1.68 gram of chlorine.
Okay, I'm with you.
The above data illustrates
dash. Now, the question is, because it is exam, you don't need to waste your time. There are some things that you already know it's only 3 laws that you're going to be thinking about. Yes or yes? You know the 3 chemical laws we talked about. Now, definitely this cannot be an answer, is out. This guy cannot be an answer, is out. I'm giving you the logic of divide and conquer. Now, definitely it is also not going to be what? Law of multiple proportion. These are simple questions that you can as well solve. So it's 10.59. Thank you very much. Somebody corrected me. 10.59 gram. Thank you very much. 10.59 gram of this one. So now, definitely it's not law of multiple proportion. David, can you please tell us why I was able to guess that it's not law of multiple proportion? Because of what? In law of multiple proportion, what do you think?
It cannot be law of multiple proportion.
And why do you think I was able to guess correctly that it can't be law of multiple?
Because the fixed mass of one.
You are trying to define. I think you are not getting it. The simple answer I needed was actually simply because when they combine together, these 2 elements, when they combine, are they in simple ratio? These things can never be in simple ratio because 5.0 gram yields 10.59, 1.50 yield 1.59. If we put this guy and this guy, are they in simple ratio? No, they are not in simple ratio. But definitely it will be law of constant composition or definite proportion. Yes, this is the answer. It is also not going to be law of conservation of mass. David, why do you think it's not law of conservation? It can never be A. Why can't it be A? David, please take us through that. Because A
cannot be law.
Balancing of what? Balancing of what? Equation. Is that not what AD talked about? Law of conservation of mass, only this balance, and we are not balancing any equation in this what regard. So most of the calculation question can either be B or C. It is C if they are in simple ratio, 1:2:3. It is B if they are in the same ratio, maybe 1:1:1 or 2:2:2. So if your answer is 1:1:1, your answer is going to be B. If they are in simple ratio like different value, 1:2:3, they are going to be in what? So how do you check? Now look at this now. This is the method I gave you. 5 gram reacts to give 10.59 gram. David, you are going to help me. So we now say 1 gram. This is the method I think. We now give X gram. That is what I thought I explained in the last class. What I say you are going to do? Just, though this one is not there because I know B will be correct. So S will be equals to, this was more like the example we did. Yes, I'm very, very sure about that. So what did I say you are going to do here? Make SOF formula to be 1 times 10.59, that's 10.59 divided by 5. You are going to tell me the answer to this. So you also do the same thing for the second one. 1.50 give 1.68. 1 gram will give X2. So how do you do that? You also make SOF formula. X will now be equals to 1 times this is 1.68 divided by 1.50. So I need the answer for the 2X. So David, you are my volunteer. What is the answer for this?
10.59.
Hope you could be more faster than that, please. But that's Ibrahim Olaniwaju is very fast with his own stuff. That is why you have the question. You should know, I can ask you, and you can start so continue solving before I even reach there. So when you are volunteering, it will be very fast.
2.118, sir.
This is 2.118. Well, I believe you. What is this one?
I can't see that. Your
1.68 divided by 1.50.
1.66.
I'm not sure this is 1.5, but let's check.
$1.12, sir.
You said 1.12.
Yeah.
So 1.12. If you want this one, are they giving us the same answer? David,
No.
are they giving us the same answer?
No.
No, because this is 2, this is 1. 1:2 is what? Simple ratio. That's 2:1. So if they are in 2:1, what will be the answer? That means what I guessed was wrong. You can see the essence of solving. What do you think the answer will be now? The answer will be what? Option what? Option C. Because they are in simple 2:1. Then if the answers are the same, that is when you go for definite proportion, which is also called law of constant composition. Do you see what I'm talking about? So sometimes it's not always good for students to guess. You can work it out in this format and get your answer. So that's that. Mute back, please. AY, please. Volunteer. You are the next person to take us through the next question.
Sir.
Thank you very much.
Okay, sir.
You can read us. Read the question to us, please.
If 1 mole of aluminium contains 6 times 10 raised to power 23 atoms of aluminium,
Yeah.
how many atoms are contained in 0.9 gram of aluminium?
Okay, so now in this question, if I am right, you can tell me if I'm wrong. That's why you are volunteering. So I think what the question is telling us that we are given the number of moles and we are given the number of atoms. Am I right?
Yes, sir.
Okay, thank you. Then they are now asking us that how many atoms are contained in a particular amount of what? Mass. Now, because this time we are giving mass of aluminum. Okay. Now, I think what we are going to do in this question, if I'm right, you can, if I'm wrong, you can always correct me, is to actually do a kind of twin equation. For example, we all know that numbers of moles, just like what you did the other time, is equals to mass, right? Over
Yes,
molar mass, just like
molar
the exact
mass.
thing you did the other time. So what is the mass, according to the question? What's the mass?
0.9.
Thank you very much. It's 0.9 gram. Please, you guys should leave your phone screen alone. I'm doing something. 0.9 divided by, what's the molar mass of aluminum? It will be given in brackets. Aluminium.
27.
Thank you.
27, sir.
27. You don't need to write gram at the back. Sorry about that. Just write it the way it is. So I'm waiting for you to tell me when you divide this by this, what's the answer?
0.03.
Thank you very much. 0.03 moles. So you now use the second formula. Numbers of moles, just exactly what you take us through the last time, equals to numbers of molecule of numbers of atoms or anything they call it over Avogadro's constant. Abi? So what's the number of moles we did now? 0.03. We are looking for the numbers of atoms. Abi? Numbers of atoms. And numbers of what? 1 mole of a substance at ST at whatever is what? 6 times
6 times 10 raised to power 23.
That's what they gave you in the question. They didn't give you to be 6.02. So you just need to be careful when you are taking. So thank you very much. So what do we get when we multiply 6 times 10 power 23 multiplied by 0.03? So I think you can just use your calculator. 6 times 0.03. What's 6 times 0.03?
6 times
0.03.
0.18.
0.18. That is what is 0.18 times 10 raised to power 23. So now from here, if that is the case, 0.18 times 10 raised to power 23, you now need to what? Shift. So if I want to shift, this is 1. I'm doing standard form. I hope you know standard form.
1.8 times 10 raised to power 22.
Thank you very much. Which is the same as 2 times 10 raised to power 22 approximately. Are you there?
Yes, sir.
Please,
yes, sir.
you guys should stop pressing anything on your screen for now, please. So 1.8, this thing is loading. It's really affecting me. times 10 to the power 22, which is
22.
approximately 2 times 10 to the power
2
22.
times 10
Thank
to the
you.
power 22.
You can mute you. I like your background. No, thank you very much. So that's good. So that's the question answer. So, and you can see what I talked about approximation. I think something like this also happened in physics class the other time. So next volunteer, we are going to do it together. Don't be afraid. It's going to be Newman. Newman, please unmute your mic.
All right, sir.
So we are not going to be afraid of the question, regardless of the fact that you might be looking at propine and the stuff, but because we are going to do it together, don't worry, we are going to conquer the question. No matter how difficult the question might be, it's definitely going to have an answer, and that is why we are doing it together. So, and that is also why you are volunteering, so that others are going to see how you are going to go through the stuff. So let's see. So I don't know if you are good to go. Read the question.
How many grams of methylacetylene, in bracket propine?
And that's what you need. Methylacetylene. You don't need the methyl. Hey, sorry about that. I have to bring it back. This thing has to come. Oh wow. Just hold on. So because I want you to see it well. And for those telling me online that the stuff is not that clear, that's why I'm trying to enlarge it. Yes. Take me through the question. Read. I'm with you.
How many grams of methylacetylene, in bracket propane, CH3, C.
I'm with you, I'm hearing. Just continue.
CACH.
Okay.
We completely discharge the color of 8 grams of bromine.
Okay, fine. Don't be afraid. I know you are afraid, but normally you know what they call propine. Propine is an example of an organic compound that is said to be unsaturated, but that's notwithstanding, it's not what is needed here. The question is testing our concept on what we call what? Stoichiometry, that is balancing equation and relating numbers of moles and stuff like that. Now, this time around, numbers of moles is mass over molar mass. This time around, we are looking for grams. That's the math. So, but that being said, what we are going to do is just now, why this one is kind of difficult to some extent is that if you cannot write the balance equation of this guy, it will be a problem. Now, propine is how many carbon and how many, propine is an example of hydrocarbon, which has 3 carbons and 4 hydrogen, if I'm right. Let's count. How many carbon here? 1, 2, 3. So you just write it in this form. Let's write the equation of C3. Are you there? Jim test? Are you there with me? Yeah, very good. C3, how many hydrogen is there? How many hydrogen? I want to see if you are following. How many hydrogen? 3 plus 1.
2.
How many hydrogen? C, 3 plus 1. How many hydrogen? 4 now.
4.
3 plus 1. So that means propine is written as C3H4. I'm taking you as someone that doesn't even know the molecular formula of propine. Do you understand? Like you don't know what propine is called, but as far as I'm concerned, I know you heard what they call propine before. And propine is written as C3H4. It's also called methyl acetylene. Acetylene are the general name of what? Of alkynes. So methyl acetylene is the what? Is the chemistry name of propine. You don't need that, but maybe in future you might need that when we get to organic chemistry. Now, this undergo a kind of reaction which they call addition reaction. Which element? Jim test. Which element is it combining with? I'm waiting for your response. Newman, what do you think? Bromine. Now, bromine is a gas.
Yes.
All gases are divalent. So bromine is written as well, Br2. Am I communicating?
Yes,
so
sir.
all gases are going to be written. If you want to write oxygen, O2, any gas in chemistry is always going to be like what's carrying this 2 under there, except the noble gases. I've talked about that. When we do periodicity and periodic table, which is our next topic, you are going to get more about this. So this is the combination. Now, there's one kind of reaction that is common to this so-called, what do you call them, organic compound, addition reaction. The first thing is that they actually break their bond and undergo a kind of reaction they call Markov-Nikov reaction. I am not going into that because that is not needed for now. But the thing is what? They are going to make sure all the bond is completely saturated with hydrogen. Now, if you want to draw C3H4, look at the simple visualization. C3H4, C, Abby, then H4. How do you think you are going to put the H? The one H will be here, and the other H3 will be here. Am I communicating as Jamb test? Are you getting what I'm trying to do? I'm trying to draw the structure of C3H4 in a linear form. But when it's combined with this Br2, I'm just showing for the sake of understanding at AY, at others, please follow through what we are explaining here. The law is what? This guy will first of all break from triple bond to double bond, then later break to what? Single bond. And when it's break, one bond is like a kind of two hydrogen. This is what I'm talking about. You know, this one has completed CH3. You can put it either at the front or at the back. Then C. Then this guy now that is now double bond, we now break to what? As triple bond. We first of all break to what? Double bond. Then when it breaks to double bond, you know what that means? That means you are going to introduce, you know what I'm talking about, then the next C. So how do you do that? You know, this is 1, 2, 3. H will come here. And this is what? H2. It's not completed. The bromine continue to react with it. Okay, it's not even reacting with hydrogen. It's reacting with bromine. But all these things is not needed for this reaction. That's the truth. What you just need to keep at the back of your mind is that when we get to organic chemistry, we are going to talk about, okay, Markov-Nikov, anti-Markov-Nikov. Whenever the bond break, it's going to what? The bromine is going to take what? The particular position. So this thing is going to happen twice. Because the first thing is, this is triple bonded atom. It will what? It will what? Bromine will react with it to form a double bonded atom. So the double bond will, one of the bond will break. Then it will give double bond. Bromine will take over the two position of that bond. Then again, it will break again to give a single bond. Then bromine will take what? Over. But you don't need that, my dear student. What you only need is just the product directly. And how do you get the product? Let me teach you how you get the product. That's what you need. How to get the product is just to write all things you think it will form. See, it will now give you C3. This is C3, the carbon here. I'm repeating it. C3. Then you have your hydrogen. How many hydrogen do you have at the beginning of the reaction? The number of hydrogen that you have at the beginning of the reaction was also what? 4 hydrogen. So it's still going to be like that. But the problem about the Br2 is that the Br2 is now combining 2 times. It's not going to be Br2, but it's going to be something like, it's going to give you something like C3, H. Oh, David network is not good. Let's wait for him. Let's wait for him so that we can actually all get this thing. Let's see. I told you it's going to first of all break down. So it's going to take 2 moles of this one. Then I think David is trying to join us. David is still not okay. David is here. It is Olanrewaju that is not here. Olanrewaju is not here. David, add your audio so that you can listen to this. That's it. So now, I believe you can hear me now. So now, I'm saying you don't need all those Markov-Nikov, whatever. Just write C3H4 combined with Br2. Now, how do I know it should be 2 moles? Because this is a what? A triple bonded atom. The first thing is it's going to break down. Sorry, apologies about that English. It's going to break down to give me a double bond, then finally give me a single bond. That is why I know that this will take 2 moles of it. So the first Br2 will be used for the double bond. Then the next one will be used for the single bond. So then I repeat everything, C3H4, then Br2. So this is the product that is going to be formed. But what I just need to understand is that whatever might be the case, I am able to satisfy this particular reaction with what I need, because this is what you are going to form at the end of the day. All these things, if we want to actually write it, the first Br will take away this one. This one we take away itself. Then we have, this is Br. We have, this is H, 2, then 3, then 4. So something like this, this should be wrong. Sorry about that. This should be H, 1. The first place, this thing is lagging. I just want to show you this. As in, it's loading again. It's loading again. Allow it to come up. Okay, I think it's back. So C3H4, we have BR2. So this BR2, we have C3. So we have 3 carbons. I draw 3 carbons. Then we have 4 hydrogens. 1, 2, 3. Satisfied. Then the 4th one, this guy is BR. Sorry. I want to clean because I want you to see it and understand. This is BR. Then the last hydrogen will come here. So I told you, this is the final product that you are going to form when that reaction actually occurs. Final product. So, but you don't need to actually know this one because it is not important. The reaction is going to take place 2 times. Bromine is going to overtake the position of the triple bond. Then it's formed double bond. And after double bond, bromine take over the double bond again to form single bond. So that is what we talked about under Markov-Nikov reaction. But for now, nobody is asking you about any Markov-Nikov reaction. This is the equation of reaction. Now, what makes this question a little bit difficult is if students don't know the equation of reaction. But nowadays, in questions you see in UTME, you don't see questions like this because if you see questions like this, they are going to write the equation of reaction in brackets for you. So you'll be able to use your stoichiometry law to solve it. So let's take it the way it should be. Nowadays, you are going to see this reaction written in brackets. So the rest of the work will be very, very easy for you to solve. So let's now solve it together at Newman. So let's do it together. Unmute your mic back. Let's talk and answer the question. So let's say this equation was given, which is nowadays questions. These questions are old school. You can see 1982 question 12. So let's see nowadays question and see how it's going to go. Well, are you there, please? Are you there? I can't hear you.
I never muted, sir.
Okay, you never left. Thank you.
I never muted, sir.
Okay, fine. So that means your background is also very cool. Now, fine. So now look at the question. How many grams of what? Of propine. So from our equation, what can you say about the moles? Now we are now, what 2 elements are we combining? You know, that's the first thing I explained the other time. Propine and what? And what? And bromine. So what do we do just like the other time? From the balance equation given, 1 mole of propine, just like the last example I did, gives how many mole of bromine? How many mole of bromine?
2.
Thank you very much. 2 mole of bromine. So I told you we are going to convert each of them to their molar mass. 1 mole of propine is what? Just like the example I did last for you guys. 1 mole of propine is you have to get the molar mass. And the number of mole is mass over. I told you how to do that. So that is 1 times propine is C3H4. What do you think the molar mass of C3H4 will be? I think that's 40. All right. Are you there?
Yes, sir.
Yeah. 40 grams. For those who don't understand what we did, we get 12 times 3 is 36 plus 4 is 40. 40 times 1 is 40, just like the exact example I did. But look at this one, it's 2 moles of Br2. What's Br? Br is 80. Br2 will be what? 160. Am I right?
Yes, sir.
160. But we have 2 moles of it. So what will be that? 2 times 160. What's that? 320 grams. Am I right? Very good.
Yes, sir.
So I hope students here understand 2 moles of Br2 is 2 times 160. Just like the example I did. You can recall to that. So now which one is reacting? We are looking for the mass of this one, so of propine. So X mass, what mass? We now yield how many of Br2 is reacting? Give guess. How many? 8 grams of bromine, right? 8 grams of bromine. 8 grams. I will take that again. 1 mole of propine is the same thing as 40 grams. 1 times 40. 2 mole of Br2 is 2 times the molar mass. 2 times molar mass was 160. We had 3. So that means 1 mole of propine yield 2 mole. You compare the equation. So that means 40, you convert it to mass, is equals to 320. How many, that is this, that's how many grams of, so X gram of propine will now yield how many grams of bromine? 8 grams of bromine. You can see I wrote propine first, I wrote bromine second. Then when I'm interpreting how many grams of propine, X gram, we now yield what gram of this gram. Then what do? We cross. The side that is married X will never be on top. So X will be equals to 40 times 8 over 320. So what's my answer? Confirm that answer.
40 times 8. Over 340. 320, okay.
Very good.
The
Thank
answer
you.
is 1, sir.
Thank you very much. So you can mute back. So the next person is going to be at David.
Yeah. Yes, sir.
David.
Yes, sir. Yes, sir. Sir?
Take me through this question, please.
All right, sir. Are you ready, sir?
I'm very much ready. Yes.
Yes, sir. 1 gram, 1.00 gram of a mixture of calcium carbonate and calcium oxide liberated 0.33 gram of carbon dioxide on strong heating. The percentage of calcium oxide in the mixture is.
Now, I actually don't know what they're asking here at first, but when you started reading, I understand that, okay, I have to write the equation of reaction. And that's exactly what I'm teaching. Because if you don't actually understand, you will not actually what? If you don't actually read through the question very well, you will not get it. So I have to just make sure I understand the question so that I will be able to what? Answer the question. So I think this is also testing me on the percentage of calcium oxide. So percentage composition of calcium oxide. So I want to clean so that I have space to can take others through so that they can actually get what we are talking about. So let's pick a pen. So you said 1 gram of a mixture of calcium carbonate and calcium oxide liberated is 0.33 gram of CO2 on strong heating. That means calcium carbonate was heated. Are you there? And when calcium carbonate was heated, it's liberated two compounds, calcium oxide and carbon 4 oxide. That is the first thing I'm going to do as a chemistry teacher. You get? So then, okay, fine. I think we are now getting it. So that means this guy initially, one gram of the mixture of calcium carbonate and calcium oxide was liberated. Calcium carbonate, and calcium oxide liberated is 0.33 gram of carbon 4 oxide on strong heating. So if I get this thing well, that means this equation I've written is also very, very wrong. So what this thing is telling me, which I think is a question error, is that calcium carbonate and calcium oxide was heated to give me carbon 4 oxide. This is what, am I right, David? Read through the language of the question. I think the second equation is what the question is talking about. Check it, read it outside, because others are also learning.
The question one?
Yeah.
I should read the question again.
Yeah, read the question again. I'm with you.
Okay. 1 gram of a mixture of calcium carbonate and calcium oxide liberated 0.33 gram of carbon dioxide on strong heating. The percentage of calcium oxide in the mixture is.
So my question is, which of the two equations do you think conform with the language of what you've read? Is it the first equation or the second one? That's what I'm asking you. Don't panic. Read carefully and understand.
Okay.
It says something and something react to give something and something. Don't be afraid.
It should be the second. It should be the second.
It should be the second one. But in chemistry, there's no such reaction like this. And that's where I'm going. Because I wouldn't like us to be wasting time or doing what is not needed. Because it should have been, I think there is an error in the question. It should have been the first one, because it is when you eat calcium carbonate 4 that is going to give you those two reactions. So I think I'm going to pass that because of, you understand, because of the nature of the question. But I think it's a very simple question. It should have been this particular of this mass reacted with the other one to give, well, Where is it? Okay, this one. So I think, okay. Let's see. You didn't finish reading the question. Okay, this is another question here now. So I think it's a typo. So David, this thing is still loading. So we are going to take the next question. So we are going to cancel that. So you read the next question for us to solve. Let's cancel this as an error of question. So the next question, please, David.
Okay, sir.
Yeah,
1.00 gram of oxide of metal X, which is bracket atomic mass 64, gives 0.80 gram of the metal when reduced with hydrogen. The formula of the oxide is.
Now, David, if I can ask you, what do you think that this question is testing us from what we have discussed? If you want to write the simplest formula of the substance, what is the simplest formula? What is the simplified empirical formula? So what do you now think we are going to do in this type of question?
To start off by finding the molar mass here, or the listen of hydrogen.
How do you do empirical formula? We first of all write the two elements because it's X and O. You write it like X and O. Then you now write their, they didn't give you percentage composition now. But in this case, they gave you the mole ratio. The mole ratio, if I'm right. What's the mole ratio of the first one? Talk. What's the mole ratio of the first one? Is 0.8, Abby. Am I right? Look at this. 1.0 gram of an oxide of metal S of atomic mass 64 gave the 0.80 gram of the metal when reduced with hydrogen. So the 0.80 gram was the mass of the substance initially. So after when it was heated, the 0.80. Now oxide of a metal X can be XO, can be X2O3, can be whatever, which we don't know. But the total number, the total mass of that thing, of that oxide, that means when it contained oxygen was 1 gram. When it was heated or when it was reduced, it gave us a 0.8. So what is the amount of oxygen in it, David? If the total number of oxide is 1 gram, the amount of X in it is 0.8. What is the amount of oxygen in it? It will be what? 1 minus 0.8. Just like the normal empirical formula. Empirical formula is always, in terms of percent, is always 100. So in this case now, we have given you S to be 80%. 80%. O will now be the remainder of 80%. What is the remainder of 80%? That is what? 20%. So the compound here is, so you need to be careful about other ways in which question can be said. You don't expect every time that everything must always be in percentage composition. Sometimes they'll put it in terms of ratio like this. So the oxide itself was 1 gram in totality. Then 0.8 gram of X was formed. Then what will be the amount of the oxygen? Because oxide is always a compound plus oxygen. Compound plus oxygen is equal to 1. But the compound itself, X is 0.8. What will be equal to the amount of O that is left? I'm waiting for you to respond, please. Yes? What is the amount of oxygen left, David? 1 minus what? 1 minus 0.8. What's 1 minus 0.8?
0.2.
0.2. So that's that about it. So always get used to this type of questions because they are also very, very common nowadays, especially nowadays, the new method. So this is your percentage composition. Then empirical formula is what we are calculating. What's the next step? We divide by the what? The what? Molar mass. What's the molar mass of compound X? Oh, yeah, answer me, no time. 64. Molar mass of compound S is 64, if I'm not mistaken. Where is it? 64. Abi? Am I right? Then yes, the second compound is what? Oxygen. What's the molar mass of oxygen? Even though it is not given, you should know. What's molar mass of oxygen? Talk now. 16. Am I right?
Yes.
Okay, calculator, please. Don't waste my time. Eight times 8 is 64. So I think this should be 0.0125. Please confirm. Others 0.0125. The next step is we divide with the smallest number. Please confirm my answer. Is my answer correct with your division with your calculator? Is the answer correct with your calculator, David? Are you not with your...
Correct.
So others, I believe you understand what we did. We are just following the normal empirical formula. Divide by the molar mass. The molar mass of X is 64. The molar mass of oxygen is always 16. So when we did that, we get this. Divide by the smallest number. So the answer is what? XO. XO is the answer, and you go for XO, which is first. So please, then the next question, I have 2 more questions. The next question will be taken by Ayomide. Let's do this together. Don't worry, we're going to do it. Please write what you want. Next question, Ayomide.
A jet plane carrying 3,000 kg of ethane burns off all the gas forming water and carbon dioxide. If all the carbon dioxide is expelled and the water formed is condensed and kept on board the plane, then the gain in weight is dash.
Okay, thank you very much. This is also a question on stoichiometry, but like I said, these are old school questions that actually test you on you have to balance equation, plus also to use your stoichiometry formulas that we've discussed about in the concept class. So now, the first thing is, because of nowadays questions, we definitely like the equation. Now, the equation of reaction here is a kind of equation we call combustion reaction. Now, the compound that is undergoing combustion is ethane. Now, when compound undergo combustion, it simply means that compound. Now, this is the equation of reaction. I'll write it for you. Ethane is C2H6. Combustion reaction, that means it bonds with oxygen. It's also a gas. Then, combustion reaction, we always give it. Even though I told you what it was given, it's giving you carbon dioxide, which is CO2, and water. So nowadays question, we write the equation of reaction for you. But I think you have to balance. So let's balance. That's the first thing. My volunteer, you and I, we are going to balance this equation. So this is the equation of reaction. It will be written for you and it will be balanced. But why are we predicting? What about if it is not written? But because it's CBT, they don't want you to waste time. They will write it nowadays and they are going to balance it. So this is the combustion equation of reaction of that rubbish. So let's balance it. If we balance, if you know how to balance, combustion reaction has a standard formula that we use to balance. But if I want to balance, this is going to give me a problem. Oxygen will be last. From here, let me start from carbon. Carbon is 2, hydrogen is 6. Hydrogen here is 6. That is 2. And hydrogen, so if I put 3 here, see my problems. If I put 3 here, see 3, that's 6. 6 here, carbon is not balanced. So I will start with carbon. Start with carbon, balance oxygen last. So if I start with carbon, carbon here is rubbish. So if I say I want to make let's say what, I will stop with oxygen. So if I try to say I want to try, okay, fine. I am going to say I want to start with carbon. Carbon, I put 2 here. The oxygen life will be affected. The life of oxygen is affected. 4 plus 1, 5. There is no way I can get 5 from 2. So that means that that particular cannot work. 2 cannot work for this. So I have to think well. So the only thing I can think of again is, oh, fine, my God. Okay, what about me now checking my oxygen and look for a way to balance my oxygen first? If I can actually, which is not always good to balance oxygen first because it's going to give me wahala. So I don't want to wahala. So the thing I will do is, okay, fine. Let me start with this carbon. The carbon look balanced, but what about me starting to make the carbon 4? Then if the carbon is 4, so what can I do to what is here? So carbon is 4. Okay, let me now say 4 here. Maybe the oxygen will be able to balance. Now, I think I should be able to take it on. And now, 4 carbons, 8 oxygen. Now, 8 plus, then I'll take this one. 8 plus 1 is 9. There's nothing I can multiply with this one to give me 9. There's nothing I can multiply with 2 to give me 9. So I can also think about, fine, hydrogen, how are you? Hydrogen, how are you? Hydrogen here is 12. 6 times 2, 12. Okay. 12. Hydrogen here is 2. 2 times what is 12? Okay. How about putting a 6 here? 6. Okay. This should help my oxygen. Let's focus on oxygen. 2 times 4, 8. Right? 8. Then 6 here. 8 plus 6, 14. This is 2. 2 times what is 14? 7. So that is the balance equation. So, but like I said, nowadays question we write this equation for you. And if you have written this equation, then they will now ask you to solve the question. So let's assume that the equation is given. So this is the equation of reaction. The question now says a jet plane carrying 3,000 grams of ethane. What did they give you now? So from the equation, that means you want to compare ethane Bonds of, that means it reacts with oxygen, means bond, combustion reaction, to form water and CO2. Water and CO2, okay? If all the carbon dioxide is expelled, you know the meaning of expelled? All carbon dioxide is given off. Then, okay, it's expelled. Where is it? It's expelled. And water form is condensed and kept up. So it's only this water that is what? That will remain. All this one, they has been released and expelled to the atmosphere. So now, that means this one has gone. It's a goner. You understand? This is only the, so that means I am actually, the question I'll say, let me see, is called and kept on the board. Only the what? Water formed is condensed and kept on the board. So that means only water is left. That means the question says, then the gain in weight is that. Okay, fine. Gain in weight. Okay. That means I'm going to compare methane and water from what I see. So this is what I'm going to do. I'm going to do a kind of simple stoichiometry stuff that we've talked about and see that. Then look at all our answers. All our answers are in terms of gram or kilogram. So that means what we're giving also here. So let's compare the moles. The first method, the thing with it. How many moles of this guy? 2 moles.
2 moles
of C2 H6. Required to give how many moles of water? 6 moles of water.
H2.
So what do? We convert it to mass. You know the logic now.
Yes,
so we get the molar mass of this one. Oh, yeah, carbon is always 12. Hydrogen is 1. 12 times 2 is 24.
24 plus 6.
Plus 6. That's 30. 30 times 2 is 60. Hope you understand why I come about 60 grams. Abi?
Yes,
done something like this the other time. Require,
yes,
and the same thing. Water is 18. 18 times 6. Hydrogen is 1. 2 times 1, 2 plus 16. 18 times 6. Do 18 times 6 for me. 144 or what? Or I don't know. Or 95. I don't know. 18 times 6 is what?
108.
104. What? 108.
108. Yes, sir.
Are you sure? 108. So 108 grams. Take it of water.
Yes,
do you understand? So now, which one did it now give us? 3,000, 3,000 grams of, so kilogram, so 3,000 kg. We now require X, So now another thing I need to check here, because one thing about all these old school questions is they can be funny. My values here are in gram, but this one is in kilogram. But until I solve, I will know. Answers will tell me if they are sleeping with their values, because you can think of how much I have to convert now. You get, but first thing first, do your question first the way it is, and check if your answer is there. You know what? If you want to make a formula, the one that is close to S will never be on top. Can never be on top. It will be 3,000 times. You said this is 108 divided by 6. You can do it directly with calculator. Since that's 50. So X is 50 times
400.
You can see 50 times, is it 50? 50 times 6 times 1. You can see that problem is emanating. The values are bigger than what you have. So that means that we have to convert. So let's convert this 3,000 kilograms to gram. You understand? Because all our these things are in grams. So I think the conversion will work now. Do you get what I'm saying? So it is until I solved, I was able to know that, oh, wow. So the conversion is very, very important. So let's do that. I think 3,000 kilograms should be what? 1,000 grams equals to 1 kg. So if somebody is converting from kilogram to gram, you multiply by 1,000. Wow. This is going to be a kind of work. Because if we are converting 3,000 kilograms to gram, we multiply by that means I have to convert this guy to kilogram. Let's convert this guy to kilogram. But that's the only way I can solve this to get an answer that is going to make sense. So can we convert together?
Yes, sir.
So here we have, is this equation balanced? Please check, is the equation balanced? Because it's important I know the equation is balanced. Yeah, is it balanced?
Yes, sir.
Okay, because what I'm saying here is not a kind of interpretation that is going to give us answer. Maybe you read the question again. Let's read the question again. Maybe I am the one that is not actually getting something here. Let's read the question again and see. Read the question from me.
Okay, sir. A jet plane carrying 3,000 kilograms of ethane burns off all the gas, forming water and carbon dioxide. If the carbon dioxide is expelled and the water formed is condensed and kept on board the plane, Then the gain in weight is dash.
Okay, the question is the gain in weight. Okay, initially there are 3,000 kilograms of this guy. So we want to know, and it expelled this one. We want to know the gain in weight. Okay. Let's do something. We are on the right track, but the only thing is that we are not actually following. So now look at the question. They say if all the carbon dioxide is expelled and water is formed, then the gain in weight. So we are not supposed to combine it with water. We are supposed to combine with what? The amount of CO2 that is expelled. That's the mistake I am making. So apologies about that. It should be this and this. So I'm going to do it in that way again. So please, it should be 2 moles of C2H6 is forming how many moles? 4
moles of CO2.
God bless you. So I think that is where the mistake. So this is the amount of gas that is being expelled, not the one that is being absorbed. So please note that. So what do we call this one? Where we do this one? This 2 times 30, 60 grams. Am I right? So let's do this one together. 4 times 12, 44. 44 times 4. I'm with you.
44. 176.
176. 176.
Yes, sir.
Yeah. So then, what was the value of this one I was given? 3,000, right?
3,000. Yes, sir.
We now need X, our way of doing it. So I said, I want to know maybe this one is in gram initially. When I saw. So cross multiply. What do we have? X will be equals to, I have 3,000 times 176 over 60. So calculator, please. I don't have any here.
8,800.
8,800. You can see it's making sense now. 8,800 kilograms. So this is the total amount of CO2 gas that was used. But that is not the answer. Look at what the questions ask. The gain, then the gain in weight. So now, how do we now get the gain in weight? Now, the total amount of weight initially is what? How do we get the total amount of weight that was expelled? Now, the total amount of weight in this reaction, we can do that by also following the same thing. Now, what? Now, the total amount of weight here is that, not this. There are 2 moles of this one plus 7 moles of oxygen initially that is reacting. These are some stubborn questions, but you just need to understand English. Now, 2 moles of this one gave us 2 times 30, which was 60.
60.
Right? 60 grams. Then they react with how many moles of oxygen? How many moles of oxygen? 7 moles of oxygen. What is oxygen? Oxygen is 16 times 2. That is 60. That's 2 times 16, 32. 32 times 7.
224.
Is what? 224.
Yes, sir.
Are you sure?
Yes, sir.
224 grams. Do you know what I did here? Just the same thing we did. Now I want to know the initial. Then 3,000 will now give us X gram. So again, we cross multiply. I want to know the amount that is left over. I will subtract the 2 answers. That's what I'm trying to do. So X will be equals to 3,000. Questions can be like this sometimes, times 24 divided by 60. So please, I don't have calculator. I can
11,200.
So this is the total amount initially. Now, what I did at AY and others was that initially this guy was combining with this guy. 60 grams of this one react with this amount. Then to now what? Then when 3,000 is now reacting, what is going to produce? What amount of what oxygen is going to produce? That's what I did. So now I now want to know. The question say, what is the gain in weight? So the gain in weight will now be initially they are 11,200 grams. Now after reacting they are 8,800. So the amount the gain in weight will be 11,200 minus 8,800. So what's the answer?
We got to 2,400.
2,400. So that would be the answer to the question. So I don't know if it's KG or G, that's their problem. I will just know that so far. So that is option D. Thank you very much. So now there are other ways I can do this thing if I don't want to follow this. So the question is kind of understanding some kind of stoichiometry law. The amount of the amount that was absorbed, the amount that was evolved when the reaction was carbon dioxide. So we focus on all the gases. This guy is a liquid. So that is why I abandon it. These guys are gases. So I focus on all the gases and react them according to the balanced equation. So please take note of that. So the last question I'm going to be doing for tonight is this. And the person that is going to take us through this is going to be Newman. And I am waiting for you to unmute your mic. I hope you're pressing this. Unmute your mic and take us through this.
All right, sir.
Last question. Yes.
The question says the ratio of the number of molecules in 2 grams of hydrogen to that in 16 grams of oxygen is dash.
What do you think this guy is testing us on? Ratio of number of molecules. How do you think, what approach
Number of
comes to your
molecules.
mind? Number of molecules, but we are not giving any. Okay, fine. Numbers of molecules, you can use that using formula that's using the Avogadro formula and getting your answer. I think that is also good. Yes, that's good. But I think there's other shortcut way you can do that. You are comparing the ratio of number of molecules of 2 grams of hydrogen to that of 16 grams of oxygen. So if you want, let me use your own approach first. I love that. Number of molecules or number of molecules. So how do we get that? We are going to do number of moles. Are you there? Is mass. Please talk.
Yes, sir.
Over what? So let's start with the numbers of moles of hydrogen. So what's the number of what's the mass of hydrogen given in the question? Please speak louder. What's the mass of hydrogen given in the question? Okay.
2.
2. What's the molar mass of hydrogen?
1.
Like hydrogen is a gas. What's the molar mass of hydrogen? H2.
Okay, 2.
Don't make that mistake, please. So that is 2. So what's the number of moles? 1 mole. Right? Now let's do in similar sequence to oxygen.
Yes, sir.
So numbers of moles, or moles as the case may be, is mass given over molecular mass. What's the mass given for oxygen?
The mass given for oxygen here is 16.
Over, what's the molar mass of oxygen? O2.
16.
Like O2. O is 16 on its own. If you don't know this thing, you go and master them. So O2 will be what? Please don't make this type of mistake. Please, it's very important. 32. So 16 over 32 is what? 0.5. Right?
0.5.
Very good.
Yes,
0.5. So the question asks you for the number of molecules. Now, if you want something from the second formula we gave to you, numbers of moles, I'm just giving you the physics way now because everybody is also doing physics, is equals to numbers of molecules over Avogadro's constant. So what am I trying to say? I don't need to disturb myself because number of mole is directly proportional to number of what? Molecules. So if I'm getting the ratio between, the question says the ratio between hydrogen ratio oxygen. And for my answer, I have hydrogen is 1. Now, I'm not calculating the number of molecules. Why? Because number of mole is proportional to number. So that means they will still have the same ratio even if I what? If I calculate, like saying the number of molecules of this one will now be 1 times 6.02. So it will be 6.02 times 10 to the power 23. That will be the answer for the first one. If I do the second one, 0.5 times 6.02. That's 0.5 is half. This will be 3.01 times 10 to the power 23. So I will now say, okay, hydrogen is 6.02. This is the way you are going to think, times 10 to the power 23. As in, if you use the second formula, that's the number of molecule answer. And for the second one, ratio 3.01 times 10 to the power 23. So when you divide 6.02 divided by 3.01, the 10 to the power 23 will cancel each other. As in 6.02 times 10 to the power 23. Ratio is division divided by 3.01 times 10 to the power 23. This gets cancelled out. So year 1, year 2. So you have your answer as 2:2/1, which is 2:1, which is the answer to the question, which makes you to be very, very correct. Yes, you are correct. You are very correct. So, but it's kind of too long. The moment, you know, so when the question is not asking what is the number of molecule, they are asking you ratio. Number of mole is direct proportional to number. So if the number of mole is 1 ratio 1.5, 1 ratio 0.5, the number of molecule will also be 1 ratio 0.5. So, but the only problem about this one is if you don't know mass again, so your answer will be 1 ratio 0.5. You'll be like, no option is having 1 ratio 0.5. Answer is not there. That's a lie. That's a big fat lie. Now, 1 ratio 0.5 is 1 over 0.5. If you divide 1 over 0.5 in mathematics, you are going to have 2. And 2 is simply as saying 2 over 1. That means the ratio is 2 ratio 1. But for formula's sake, calculate the number of molecules of each of them by using the formula number of mole is 1 equals to number of molecule times, you know, this guy is always 6.02 times 10 raised to the power 23. So if you calculate 6.02 times 1 for the first one, you're going to get this answer. Then the second one is 0.5 times 6.0, you're going to get this answer. Then they say the ratio of hydrogen, the first answer was hydrogen over this. We're going to go 2 over 1. Then the answer to the question is going to be option A. So that is that about that, dear students. That is the end of today's class. The remaining question I'm going to give to you is assignment, which you have to do. Assignment, which you have to do. So in the next class, we are going to the next chapter, which we are going to talk about periodicity, periodic table, electronic configuration, quantum numbers, discoveries, and name of scientists, as well as other things. Because next class is Friday, it's a combination of class. We can't finish. We are going to just do it anywhere we stopped. We are going to continue on the Wednesday for the next chemistry class. So I'll see you guys soon. But before that, if you have any question, you can actually talk now and let me know. Any questions so far, so good? And if there is no question, write in the chat box that you don't have question while I show you your assignment. Fine. So assignment, student, assignment. Assignment, no questions, okay. Okay, David says no questions. So assignments, as usual, screenshot. So screenshots, if you are true, you just write done in the chat box. Write done. This should be the end of our class, this 10. Write done. Then I give you this next page, which is the last one. If you are true, write done on the chat box, please. Don't waste your time. You have to go and rest. You've tried. I immediately said done. Okay. Thank you. Then the next one, still on assignment. Yes, this is the last one for you guys. So please screenshot this as well. Screenshot this. You can see you have numerous questions to solve, to tackle. Done. People are saying done. Now, please, these assignments are very important to me. They're very of importance to me. So, and on that note, my dear student, I am going to end this class. I'm going to see you on Friday. For biology students, please join your classes. I think, do you guys have classes tomorrow? David, unmute and talk to me. You guys have classes tomorrow. When is your next class in biology? You had classes yesterday.
Yeah, we have class tomorrow, sir.
Okay, you have class. What time is the class? Because I think AY is new.
8 o'clock.
8 o'clock. So at AY, 8 o'clock. Okay, to 10. So at AY, their biology teacher is on WhatsApp. So maybe you guys exchange, please, on the chat box, you can exchange your numbers now. I'm giving you an opportunity to do that now. Exchange numbers so that you can actually, I'm going to make either David or James an admin, so you can add him to the group so that he can also join the biology class as well. So guys, exchange number. I'm waiting for you guys to exchange number. Drop numbers in the chat box. Do that now so that you guys can add him up to the group. So that is David's number. AY, you can as well drop your number. Okay, fine. Please do that quickly because I want to end this class. We are through with today's class. So guys, Okay, you guys are writing. Okay, just exchange number. Let's also drop this. So I believe if you are true, saving numbers, just write done so I can end this section. I'm waiting for your done. Done. I already said done. So that's that. You can, okay, right. So guys, see you guys soon. Thank you. Take care. Bye for now.